Hi class. Today we're going to be talking about basics of probability. Okay? Um, so if we look at the basics of probability, um, one of the first things that I'd like to talk about is just our definition for this class as pertains to this class. Now, I do want to emphasize that there are multiple ways to define it, but the way that we are going to define it in our class is the proportion of times an outcome has occurred or would occur in many trials. This is often looked at as like experimental probability. Okay, that's what we're going to be doing. How we're going to be defining it in this class. Okay, now an example of this would be the weather. Okay, the weatherman might say that there is, and I hope I'm reading this right, that this is like a 15% chance of rain, okay, at 11 a.m. Okay, so there's a 15% chance of rain at 11 a.m. On Monday. Okay, so 15% chance of rain. I believe that is right. For sure, this might be a more accurate number, is there is a 70% chance that it rains today. Okay. Now, this was done on Monday because our lecture was yesterday. Our live lecture was yesterday. But let's just go with the 15%. If I'm reading this wrong, those of you who know weather, please let me know. Okay. If we look at the weather report for today, it says there will be a 15% chance of rain at 11 a.m. Now, what does this mean? Well, what this means essentially is that the predicted amount or the predicted percent chance that it will rain is 15%. Now, this means that 15, essentially what it's saying is 15 out of 100 approximately number of times, if today were to occur, 15 out of 100 times it would rain. Now, where are they getting this data from? They're getting this data from previous days that had similar characteristics as today. Okay, so with respect to the chance of rain, this would mean that on all days in the past with similar weather patterns, that 15% of those days would result in rain. Therefore, our prediction for whether it would rain today, based on those weather patterns, that it would be 15%. Okay, so that is how you interpret that, and that is the approach that we are going to be taking towards probability in this class. Okay, now this leads us into another definition, which is called the law of large numbers. The law of large numbers essentially tells us that as you collect more and more data, the accuracy of your data improves. Or in other words, your experimental probability approaches your theoretical probability. What do I mean by that? Okay, well, in an example, like when you flip a coin, the thought is that it should be 50-50, right? So 50% of the time you will flip heads and 50% of the time you will flip tails. Now, if you were to flip a coin 3 times, right, the proportion could be 0.33, right? You flipped, well, 1 head, 2 tails, and that wouldn't be unusual. But if you were to say, okay, the probability according to of flipping heads according to your 3 trials is 33%. Now, obviously, that is not true because we know that when you flip a coin, as long as it's a fair coin, it should be 50%. What the law of large numbers says, essentially, is that the more you flip, the closer your proportion, according to the number of your flips, is going to be closer to 50%. So in other words, if I were to flip it, 5 times, right, the chance that I'm going to get a number that is close to 50% is going to be smaller, much smaller than if I were to flip a coin 1,000 times. Right? If I were to flip a coin 1,000 times and I were to get 700 heads, I would doubt whether the coin is fair or not, right? Whereas if I flip a coin 10 times and I were to get 7 heads, I'm probably not doubting that this coin is not a fair coin because my sample size is so small. That's essentially what the law of large numbers is getting at. The more number of times you flip a coin, the closer we're going to get to the true probability of the scenario. Okay? So what I want you to do is I want you to do this homework. Okay? It's illustrating what we just talked about in the past few slides. I have an alternate assignment if you don't have dice at home. If you do have dice, it's probably better to use dice, but if you don't, then you have an alternate assignment at home. Continue to stay safe. Miss you all. Take care, guys.